Okay, so the next topic in this chapter is related to the interference and coherence. Basically, interference is almost like based on the same principle of superposition. We already discussed about the superposition, principle of superposition, in which two or more than two waves overlap and their resultant displacement is the sum of the displacement of each wave, right? So interference is like the same concept. So in interference of wave, we are going to study the same concept, the combination of two waves or more than two waves, if they are going to combine with each other or want to overlap each other. So only difference is in superposition. We discussed that both waves are moving in different direction. In interference, light may be or light waves may be move in the same direction. So that is only the difference we discuss in superposition and interference. Because in interference, it is not compulsory that waves are always move in opposite direction. The waves may be move in the same direction too, just like the headlights of a car. If we observe the headlights of a car, so the both light source are moving in the same direction, and the lights from that source also move in the same direction. So after traveling through some distance, they will interfere with each other, and that is the concept of interference, right? So in interference, waves will also overlap, and again the same concept, when they overlap, so their resultant displacement, so their resultant displacement is the sum of visual displacement. And we also discuss about the concept that if same component of waves are going to combine with each other, so there will be a constructive interference, right? So there is another concept related to the constructive interference and destructive interference. So if we talk about the constructive interference, so in constructive interference, we can say that the waves or both waves are in same phase. So both in same phase. What is the meaning of phase? Because we never discuss about this component regarding waves. We discuss about wavelength, frequency, displacement, speed, like all these components, but we never discuss about the phase in waves. So what is the concept of phase in waves? Actually, if we talk about the last time we discussed about the upper component of wave, lower component of wave. So if crust combines with the crust, so there will be a constructive interference. And if opposite components are combined in the waves or interference of wave, so there will be destructive interference. But there is an other concept that if waves or both waves are in same phase, so there will be constructive interference. So actually, what is the meaning of phase? So if we consider two waves, let's suppose if two waves are moving in same direction, or we can say that moving with different formation as compared to each other, like this. Okay, let's suppose if we continue with two waves, one wave is moving like this, this is our first wave, right? And the second wave on the same graph. Let's suppose this is our second wave. It may be start like this. Let's continue from this point. Okay, so basically there may be any formation of two waves when they are going to interfere with each other, or when they are going to generate from their original point. And if we observe these two waves, so green wave starts from the origin. So this is the starting point of the green wave, and this is the starting point of the purple wave. So this is the difference between the formation of two waves. So actually same phase means if both waves are generating from the same point. Let's suppose if this purple line also starts to move from this same origin, so then both waves are in same phase, right? And if you want to find out the change between the phase of these waves, so let's suppose if we consider the first wave, so the first wave completes over here. This is our green first wave. So this is the total length of one wave for the green one, right? And if you want to mark the one complete wave for the purple line, so let's suppose if we take this reference line from the origin, and this is the ending point for one wave. So this is for the second wave. The second one, this is for the first one, right? Any confusion?
No.
Okay, now what you need to do actually, let's suppose if there are markings on the graph also, and the markings are like this. We started from 0, and this will be equal to, let's suppose, we consider different points, like this will be 100 and this will be 200. So actually first wave, if we consider the first wave, the first wave started from 0 and ending up to 100. Consider the second wave. So second wave ends up at 200. So basically we can observe that the second wave ends up at 200 and first wave ends up at 100. So the starting point of the first wave will be equal to 0, because it starts from the origin. And for the second wave, it starts from around 60 or 70. So we can easily observe that there will be a difference of 70-degree between two waves, because the starting point of the first wave is 0 and the starting point of the second wave is 70. So that's why there will be a difference in phase. So actually it depends upon the starting point, depends upon the formation of the wave. So we can also use an other term in constructive and destructive interference, that both waves are in same phase or both are in different phase. Just like for destructive interference, we may use the concept of antiphase. Destructive interference, we can write it as both waves are antiphase. And it's completely opposite 180-degree from each other, because after 180-degree, both will be in the opposite direction. So that will give you the concept of destructive interference. And if you want to discuss about the graphical representation, so the graphical representation will be the same as we already discussed in the first topic of superposition, like this. So this is,
Okay.
yes. So this is the same concept. The interference, only the difference that they're not moving in the opposite direction, and we are having some new concept like the phase of the wave. Either they are moving in same phase or in different phase. And one or two important things for this interference concept is, let's suppose the first one is, and one point you already know that you already mentioned in the last class, that let's suppose if both ways are not completely anti to each other, so resultant depends upon, or we can say that resultant will be in between zero and maximum, right? So it depends upon the position. So it's not always like zero or maximum. There will also be a middle value somewhere between zero and maximum. It depends upon the situation, but we mostly discuss about 0 and 100, because if we got the 0 and maximum concept, so we automatically consider, and we automatically got the concept of the any other value between 0 and 100. And one more thing, if they ask in exam that what is, or define what is meant by coherent wave, so coherent is a new term for the wave also. Coherent means if two waves have same frequency, same frequency plus constant phase, like formation of the wave completely, so their distance will be almost equal from each other. So that is the concept of constant phase that we already discussed. Let's suppose if we consider these two waves, so their phase will be constant after each and every interval, and if their frequency is also same, then both waves are known as coherent waves, right? It is not compulsory to have same phase. If they have different phase, so their phase difference must be constant, right?
Okay.
Yes. For example, let's suppose if we just consider two general pattern of the waves for coherent, so their formation will be like this. So the formation for first wave will be like this. This is the formation of first wave, and this is the formation of the, as you can see, both are in antiphase, right? Both are completely opposite to each other, but their wave difference is constant, right? If we consider first initial point, so we can easily that there is a complete difference of 180. Both are completely antiphase, and same goes for this point. So their phase difference is constant. So that gives you the concept of the coherent waves, when two waves are same in frequency and having constant phase difference, right? So this is the concept of coherent waves, right?
Okay.
And let's suppose if we want to write some example in our daily life, so if we talk about the coherent wave, so laser light is the example of coherent wave, because you observe that it is, laser light is completely sharp and focused on a single point, so that's why it is known as a coherent. And if we consider filament lamps that we use in our daily life, so basically that was incoherent wave, because they spread, and their brightness depends upon the position. But for laser light is completely focused on a single point, so that's why it is completely coherent, because its phase difference and frequency remain same. So this is the concept of interference. And let's suppose if we want to consider the concept of interference in wave form. just like to demonstrate in the wave structure or in the graphical representation of wave. So how we are going to demonstrate two sources of, let's suppose if we are having two sources of wave and we want to interfere those two waves, so their interference will be like two source interference. So basically, we are going to discuss about two important practical applications. One is the young double slit experiment, and second one is diffraction grating. So these two are practical explanation of the wave nature of light. But before that, let's discuss about some basic wave pattern. That if we are having two different sources, so how we are going to discuss about or how we are going to mark their constructive and destructive interference. So let's suppose if we are having two sources of wave, one source is placed over here and the second source is placed over here. We are having two sources and both are going to produce the waves. This is source number two, and let's consider their structure of wave. So there will be a pattern of crust and trough. The regular line of crust and the dotted line shows you that of the wave, right?
Okay.
So this is the wave formation for source number two, and if we consider the same pattern for source number three, also same, the dotted line and the regular line shows you the crust. At the concept of interference over here, and we need to see that how that interference look like and how we can identify the crust and trough and the constructive and destructive interference in the wave pattern, because normally we discuss about two waves only, but let's suppose if there are two sources and both are placed at same point, so what will be their interference looks like. So now they are going to intersect there, so it will be like this. We can also extend this purple one more time. So you may consider as many ways can, so that will give you the interference. Must we can observe both waves are going to interfere with each other and they are going to intersect with each other. So that is the concept of interference. Now let's discuss about that how we can identify their constructive and destructive interference from these waves. So let's suppose let's first mark the intersection point. So first of all, let's consider only a regular line where two regular lines are intersecting with each other. So this is one point and this is the second one. This is the third point. We are also getting same interpreter. This is also same. This is also same. And I think this is only regular lines which are intersecting with each other, right? So basically, when two regular part of the lines are intersecting, so basically, what is the concept of these two waves? So the regular line shows you the crust, dotted line shows you the trough part, right? So when two regular lines intersect with each other, so what is the meaning of that when two regular lines intersect with each other?
They're intersecting.
They are intersecting and we are getting constructive interference or destructive interference.
I think it's gonna be
Okay, let's suppose,
destruct.
okay, let's suppose if we consider this point, point number one. So this is the crust of first wave, right? Because it is a regular line. And this is also a crust of second wave because it is also a regular line. So basically when they intersect at point number one, so it means that crust plus crust. So that will give you what? Constructive interference, right?
Okay.
So one, two, three, four, five, six. So these are 6 points where we are interference because crust is going to be combined with the crust. So that's why we are getting constructive interference. So one, two, three, four, five, six. We are getting constructive interference. And what about the dotted lines? If we want to identify the dotted lines also, so that will also give you the concept of what? Constructive interference. Because trough line shows you the trough. So when trough is going to be combined with the trough, so that will also gives you constructive, right? And this one also. So now we have some more points where we are uh, observing that there is constructive interference in the wave. Is it clear? Any confusion?
It's clear.
Okay. So now we have some more points like point number 7, point number 9, point number 10, point number 11, number 12. So now again we got 6 more points that will show you the concept of constructive interference. So 7, 8, 11, 12. We are also getting constructive interference over here. That dotted line shows you the trough part, so that will give you constructive interference, and when crust comes by crust, that will also give you constructive interference. Now, if we talk about the remaining point where there is a mixture of waves, like this point, this one, this one. So, what is happening when dotted lines and the regular line combines? So, when a dotted line combines with the regular line, so there will be a destructive interference, right? So let's see a different number. So let's suppose these green line A, B, C, D, E, F, G. So basically A, B, C, D, E, F, G gives you the concept of destructive interference, right?
Right.
Confusion in the diagram.
Yes.
If you want to ask any question from the diagram, any confusion in the diagram, you may ask. Because this is very important to identify because most of the time in questions, we are just getting a diagram form and we need to identify that where will be the crust, where will be the trough, and where will be the constructive interference and where will be the destructive interference. So basically, dotted line shows you the Yes.
Yeah, yeah. So like the dotted line is the crust.
Dotted line is the trough. You may choose dotted line as a crust also. It's up to you. It is not compulsory that you may choose regular line as crust. But I already mentioned that the regular line shows you the crust and the dotted line shows you the trough. So let's
So
suppose,
when the crust and the trough intersect, that's going to be destructive. And when the crust and the crust or the trough and the trough intersect, it's going to be constructive.
yes, simple. In previous class, we only discussed in theoretical form. Today we are talking about in the graphical representation, right?
Yeah.
So that is the concept. So this is the wave pattern to identify the crust and trough from the diagram. And it may also be, or this experiment can be done with any source like sound source, light source, electromagnetic source, right? Because all are the types of wave. So it can be produced from any type of source, right? It's not compulsory that we always use light. So you may also use sound waves to produce this type of interference, right?
Right.
Okay, now we are having two concepts. The first one is related to the same concept, but there is only a difference. We are again going to use two sources, but we are going to talk about interference fringes. Interference fringes. Interference fringes means basically this experiment also known as young double slit experiment, right? I will write over here that this experiment is also known as Young's double slit experiment. Actually, we need to use a coherent light, so that is a difficult task to interfere same light at that time. So that's why in this experiment, he uses same source and he split the same source into two different form by using a slit like this. So when same source is going to be enter from left hand side, this is the source from which waves are going to be generated. So when they reach these two different points, you already know the concept of diffraction. When there is a narrow and a wide opening in the slits or through the obstacle, so they will move in different direction, right? So this is our slit number one. This is slit number one, and this is our slit number two. Okay. And let's suppose if we consider a screen in front of these slits where we are going to observe their dark or bright fringes. So this is our screen, and when light is going to move from left to right position. So let's suppose this is our slit point S1, this is our slit point S2, and we are going to consider only a single screen because you already got of this wave pattern, right? So same wave pattern is going to strike over the screen, like just like the projector. So when we start the projector, so a beam of light is going to be hit on the screen, and we observe different colors and different type of images and videos on the screen. So same goes over here. When light waves from slit 1 and slit 2 are going to move towards the screen and they interfere with each other. So let's suppose if we consider a specific point which is mentioned over top over here, which is close to the screen. And if we just combine them like this, that this is the distance from slit 1 to the screen, and the distance between the screen to the slit 2 is this. Actually the problem is if we consider a central point, right? So at central point both slits have equal distance from their starting point. Okay, let's suppose this is the starting point for slit 1 or the light source from slit 1, and this is the starting point for slit 2 or the starting point of light from slit 2. And if there the waves or the interference of waves is going to be occur at different position from the center point, so there must be some difference in their path, right? If you observe that, so in your observation, this first line is shorter than the second one, right?
Yep.
And why it is this? Because you know that the distance between slit to that specific point is greater. So our main purpose is to find out the path difference between two waves if they are going to intersect at different point from their original position. So to find out the uh, path difference, we just simply draw a perpendicular over here. This is our perpendicular line, which is completely 90-degree with the source of slit number 2. So actually this distance gives you the concept of the path difference, right? Because this is the additional distance or this is the additional path which is covered by the second source or the slit number 2 of light. Okay, so this is our path difference. If we subtract this path difference, so the length of line number 1 and the length of line number 2 will be equal to each other. So this path is the additional path. So that's why we use the concept of path difference, right?
Right.
And there may be constructive interference on the screen and there may be destructive interference on the screen, right? So it depends upon their phases, depends upon their movement, right? So we are not going to talk about specific at this point because we don't know that either we are going to have constructive interference over here or destructive over here. So let's suppose if we just want to write that either it may be constructive interference or it may also be destructive, because we are not sure, we are not explaining the concept of constructive and destructive over here, but we only need to know that let's suppose if there is constructive interference at this point, so the path difference will be equal to, so the formula for path difference will be equal to n lambda. And what is the meaning of this n? N gives you the concept of, let's suppose starting from the center, this is our center point, right? So starting from the center and we start moving in vertical upward direction, just like the interference pattern. You observe that if we start from the center, this is our center point, this is our center point. So from center point, it is not compulsory to get constructive interference very quickly or destructive interference very quickly. It depends upon the interference, right? So same concept goes over here that from the center point, it depends upon the position, it depends upon the distance from center point, that after how many distance or after which length we are going to have constructive or destructive interference. Let's suppose this is our point number 1 and at this point number 1, we are getting our first constructive interference, right? So basically, n shows you that n is equals to 1. 1 means your first order, first interference, that is constructive, right?
Right.
And it may continue like the second, the third, then the fourth, and so on. So this is the concept of n. Whenever you get the first interference, so that will be your first order. So n will be equals to 1. Then after moving from the first point to the second, so at second point, you got your second order, and that is known as your second constructive interference, right? And same goes for the destructive. Let's suppose if this interference of wave is destructive. So at this point, we may get destructive interference also. It is not compulsory that it will be constructive. So we may also got destructive interference. So their path difference will be equal to, so the formula for their path difference is completely different from constructive. So will be equal to n plus half lambda, right? So this is the formula for part difference of destructive interference. And the meaning of n remains same. Whenever you find the first destructive interference, so that is your first order, and at origin or at the center point, we are having n equals to 0, right?
Okay.
Any confusion?
No.
Okay. So basically, this is a complete pattern related to the interference for two sources. And let's suppose if we want to mark this n is equals to 1, 2, 3 on the diagram. So let's suppose if we consider a screen uh, at different position, let's suppose the screen is over here. The same screen that we already drawn initially. So this is the same screen. And let's suppose if the wave pattern on the screen will be like this. So this is the wave pattern we are getting on the screen. And what actually this wave pattern shows you, this shows you, let's suppose, this is our central point, right? Central max, because this is completely at the center. It's aligned from the initial position, right? And let's suppose if we start moving in upward direction, so this will be n equals to 1, n equals to 2, and same goes in downward direction, that n equals to 1 to 2, right?
Yeah.
And you observe that we just mention n values in the peak one, right? So these peak values gives you the concept of maxima, the constructive interference, right? So
Yeah.
these
Yeah.
are our maxima, and the rest of the other one are known as the minima, right? Interference. Okay, gives you the of minima.